The Northern Lights, or Aurora Borealis, are one of nature's most stunning spectacles, captivating observers with their vibrant colors and ethereal movements. To understand the reasons behind this phenomenon, we can explore a variety of scientific concepts, historical context, cultural significance, and the conditions that allow the auroras to manifest. Scientific explanation of the Aurora Borealis. The sun's influence. The northern lights originate from the sun. Solar activity is a major player in this natural light display. The sun emits a continuous flow of charged particles known as the solar wind. This wind is composed mainly of electrons and protons. During periods of increased solar activity such as solar flares and coronal mass ejections, a greater number of these particles are released into space. Earth's magnetic field. The Earth is surrounded by a magnetic field which protects the planet from the solar wind. When charged particles from the solar wind reach Earth, they are drawn toward the magnetic poles. The interaction of these particles with the Earth's magnetic field leads to a complex dance of energy, resulting in the creation of the auroras. Magnetosphere, the area around Earth influenced by its magnetic field. It serves as a shield against solar wind. Magnetic poles. The solar wind is funneled toward the poles where the magnetic field lines converge. Collision with atmospheric gases. As the charged particles from the solar wind enter the Earth's atmosphere, they collide with gas molecules, primarily oxygen and nitrogen. These collisions excite the gases, causing them to release energy in the form of light. The different gases produce different colors. Oxygen, at higher altitudes above 150 kilometers, emits red and green colors. At lower altitudes, below 150 kilometers, it typically glows green. Nitrogen, on the other hand, can produce blue or purple colors when it collides with charged particles. The science of light production. The phenomenon can be explained through the principles of atomic and molecular physics. Excitation. When gas molecules absorb energy from the colliding particles, their electrons move to a higher energy level. Emission. As the electrons return to their original state, they release energy in the form of light. The wavelength of the emitted light determines its color. Geographical and temporal factors. The best places to view the northern lights are within the auroral oval, a ring-shaped region around the Arctic and Antarctic. Locations such as northern Canada, Alaska, Norway, Sweden, and Finland are prime viewing spots. The phenomenon is most visible at high latitudes due to the Earth's magnetic field geometry. Auroras are more common during winter months when nights are longer and skies are darker. The best months for viewing are typically from September to April. Additionally, solar activity follows an 11-year solar cycle, meaning that auroral displays can be more intense during solar maximum periods. Throughout history, the northern lights have captivated and inspired countless cultures. From ancient myths and legends to modern scientific understanding, these dazzling displays have left an indelible mark on human imagination and curiosity. In some traditions, the lights were seen as spirits dancing across the sky, while in others, they were thought to be reflections of battles fought by gods. Today, they continue to be a source of wonder and a reminder of the natural beauty and mystery of our world. Indigenous interpretations. Various indigenous cultures have rich mythologies surrounding the northern lights. For instance, some Inuit tribes believe the lights were the spirits of their ancestors or celestial beings playing games. And in Norse mythology, the Vikings thought the auroras were reflections of the armor of the Valkyries, female warriors who chose those who may die and those who may live in battles. Scientific discovery. The understanding of the auroras has evolved over time. Early observations were often attributed to supernatural forces, while modern science has provided a clear explanation based on physics and astronomy. Key figures in the scientific exploration of auroras include Galileo Galilei, who first coined the term Aurora Borealis in the 17th century, and Christian Birkeland, whose work in the early 20th century helped establish the link between solar activity and auroras. Impact of modern science and technology. Space weather monitoring. Advancements in technology have improved our ability to monitor space weather. Satellites such as NASA's ACE or Advanced Composition Explorer and NOAA's DSCOVR, which stands for Deep Space Climate Observatory, provide real-time data on solar winds and geomagnetic activity. This allows for better predictions of auroral displays. Future of aurora research. Continued research into the auroras is essential. Scientists are investigating several key areas: climate change, looking into how changes in the Earth's climate may affect the frequency and visibility of auroras; solar activity cycles, to better understand how the sun's behavior impacts space weather and the Earth's atmosphere; and technological advances which focus on improved models for predicting solar storms and their effects on Earth. Conclusion: the northern lights are not only a breathtaking natural phenomenon, but also a complex interplay of solar physics, atmospheric science, and cultural heritage. As our understanding continues to evolve, so too does our appreciation for this extraordinary display of nature's beauty. The aurora borealis serves as a reminder of the dynamic relationship between our planet and the cosmos, inspiring wonder and curiosity in all who witness it.